Hello my dear students, today in this session we are going to solve the NEET 2023 paper related to physics subject. In this video we will discuss some of the questions that were asked in NEET 2023 and that are related to your class 12 physics. Let us take one by one questions. The first question says there is a series RLC circuit. We are provided with three elements R, L and C. The value of L is 10 millihenry. The value of capacitance is 1 microfarad and the value of resistance is 100 ohms. Okay. Now we have asked about the frequency at which the resonance occur. As we all know, the resonance is a special condition of series RLC circuit where we get XL is equal to XC. Means the inductive reactance is equal to capacitive reactance. Inductive reactance is equal to capacitive reactance. By putting the value of XL is equal to omega L and value of XC is equal to 1 upon omega C, we can balance equation as omega square is equal to 1 upon LC. This equation comes out to be omega square is equal to 1 upon LC. Now we have to calculate the value of omega. We will just simplify the equation as 1 upon root LC. As we all know, omega is known as the angular frequency that can be converted in linear as omega is equal to 2 pi f 1 upon root LC. On solving for f, we get f is equal to 1 upon 2 pi root LC. By putting the value of L and C, we get the frequency as 1.59 kilohertz. That is required option number 3. This question is related to resonance technique, that is a special condition of series RLC circuit. Now we will move to the next part. The next question is related to the current and voltage strategy. The question says the magnitude and the direction of current in the following circuit. We are provided with a circuit given having some energy sources and some dropping element. We have to calculate the magnitude of current and the direction of the current. As we all know, there are two types of voltage source. First voltage source is 10 volt and other is 5 volt, and current always flows from higher potential to lower potential. So according to Ohm's law, current is equal to voltage upon resistance, and the voltage acting on this will be the difference of these two voltages. Difference will be 10 minus 5 upon the total resistance of the circuit. On calculating the total resistance, we get 7 plus 2 9 plus 1, that is equal to 10. So the total required current is 5 upon 10. 5 upon 10 can be solved as 0.5 ampere. And as we see the polarity of the voltage, that is 10 volt and 5 volt, the current will flow from A to B because it always flows from higher potential to lower potential. Okay, this is all about, and the required answer for this is option number A, from A to B through E. From current will flow from A to B through this point E. This is simply the application of circuit laws. Now, the another circuit is also related to some energy sources and some dropping element. The question says the galvanometer G does not show any reflection. In this circuit, the galvanometer does not show any reflection. That means there is no current flowing through galvanometer. And according to the geometry of figure, if there is no current through the galvanometer, that means no current flowing in this branch. Okay. The question is about the calculation of value of this R. We have to calculate the value of R. We know simply the formula for R is equal to voltage upon current. For calculation of resistance, we have to find the voltage and current. Now, first we calculate the value of current flowing in this 400 ohm resistor. For calculating the value of current, we can see there is a voltage source of 10 volt. So there is a polarity of 10 volt at this portion. And now if there is no current in this branch and there is a voltage source of 2 volt, so we know these branches are always in parallel and the voltage of the parallel branch is always same. So the 2 volt shift to this. Now we have to calculate the current in 400 ohm. One side is 10 ohm and other is 2. So the difference will be 10 minus 2 upon resistance is equal to 400 ohm. So the current flowing is 1 upon 50. So the current is 1 upon 50. That is the required value of IR. we have calculated the current as 1 upon 50 and the voltage is 2. So putting the value of voltage at 2 and the value of current we get resistance is equal to 100 ohm. The fundamental concept behind this question is we have to calculate resistance, and according to Ohm's law the resistance is calculated as the ratio of voltage upon current. That's why we have calculated the value of voltage and current. Moving to the next part, the chapter behind this numerical, the concept behind this numerical is the electrostatics. The question says there is an electric dipole which is placed at an angle of 30 degree. As we all know, dipole consists of two charges of equal magnitude but opposite sign, having an angle of 30 degree with electric field intensity. The value of electric field intensity is 2 into 10 to the power 5. It experiences a torque equal to 4 Newton meter. Now you have to calculate the value of charge on the dipole if the dipole length is 2 centimeter. This is simply a formula based numerical which can be solved by this application of formula. As we know, the formula for the torque is equal to PE sin theta. In question the value of torque is given as 4, so we put torque is equal to 4. The value of P means electric dipole moment, that is equal to charge into length. So we have simplified P as Q into L. The value of Q is we have to calculate. The value of length is in 2 centimeter. So we convert 2 centimeter into meter. Next term is E. The value of E is given as 2 into 10 to the power 5 and sin theta is provided as 30 degree. So by this putting the value and calculating the value, calculate the value of Q by transposing the equation, we get Q is equal to 2 into 10 to the power minus 3. That is option number 3. This is simply based on the application of this formula. Torque is equal to PE sin theta and P is electric dipole moment, that is nothing but the product of charge into distance, or we can say the length of dipole. The next question in this chapter is about the magnetic dipole moment. Magnetic dipole moment, what is it question? The net magnetic flux through any closed surface is, we are provided with an closed surface. Any closed surface. According to question, we are provided with an closed surface. The question is, what is the value of net magnetic flux through this? Okay. So the magnetic field exists in closed loop, monopole does not exist. If you have studied the Gauss law for electrostatics, there is a Gauss law for magnetism. It says the magnetic monopole does not exist, means there will be not only available north and will be paired with always south. No circuit will be there only north, or no circuit will be there only south. North and south pole always exist in pair. That's why we can say dipole. Dipole means two polarity, north and south. So monopole does not exist. So the net magnetic flux through any closed surface is 0, means net magnetic flux is equal to 0. Net magnetic flux is 0 means magnetic flux is given as B into dA, that is equal to 0. So the concept behind the net magnetic flux is 0, that the product of magnetic field into area vector is always equal to 0. That is the required Gauss law for magnetism. Now proceeding to the next part, the next question is related to the work function of an element. Question says the work function of cesium, potassium and sodium are. We are provided with the work function. As we all know, work function is the minimum work done or the energy required to escape an electron from a metal. So the values are 2.14 electron volt, 2.30 electron volt, 2.75 electron volt respectively. If the incident electromagnetic radiation has an incident energy of 2.20 electron volt, which of the photosynthetic in the surface may emits photoelectrons? The basic concept behind the photoelectric effect is that if the threshold frequency or the energy of photon is greater, so only that condition exists, the electrons may be emitted. So we have to calculate in which case there may be photoelectrons emitted. So as we know, energy of photon is 2.20 electron volt. Energy of photon is provided as 2.20 electron volt. Work function of cesium is 2.14 electron volt, 2.30, 2.75. So energy of photon is 2.20, we have to compare the energy of photon with this 2.14, 2.30, 2.75. So we can see that the energy of photon is only greater than the energy of cesium. It is less than the energy of potassium. It is less than the energy of sodium. So energy is this. Work function we can calculate the formula according to. So we can say the option. It is clear that the energy of photon is more than the work function of cesium. Only the electrons of cesium will be out. That is option number 4. In this type of numerical, we just have to see the energy of photon is greater than the work function of which element. Electron will be only emitted if the energy of photon is greater than particular work function. In this numerical, we see 2.20 is only greater than 2.14. It is less than 2.30. It is less than 2.75. That's why photon will be unable to emit the electrons from this. Okay, the answer is option number 4. Now, the another concept is related to also the wavelength concept, series related question. The question says the minimum wavelength of X-ray produced by an electron accelerated through potential difference of this. We have to calculate the value of lambda minimum. Now, according to the concept, lambda minimum is equal to SC upon EV. Yes or no? We can simply see that there is a relation of inverse between wavelength and potential. Lambda minimum is inversely proportional to V. So the option number, correct option number is first. It shows there is an inverse relation between wavelength and potential. Okay, that is simply the formula based concept. Now the other question is related to the transformer technique. As we all know, transformer is a static device used to transform power from one circuit to the another. Transform perform two types of work. First is the step up of the voltage, another is step down. Now according to the question, we are provided with a 12 volt source, 60 watt lamp is connected to the secondary of step down transformer. As we all know, transformer is a device which is used to transform power. One side is the primary side and other side is the secondary side. Where supply is connected, this is primary, and from the secondary load is connected, it is secondary. Question says there is a load of 12 volt 60 watt lamp about the secondary of its step down transformer. Step down means it is lowering the voltage supply, whose primary is connected to AC means of 220 volt. So the rating of primary is 220 volt and the rating of secondary is 12 volt 60 watt according to question. Assuming the transformer to be the ideal, this is the key point of the question where we get the hint from the question. Transformer is ideal. What is the current in the primary winding? Simply as I say, transformer is a static device used to transform power from primary circuit to secondary. And if the transformer is in ideal, ideal means perfect. So perfect transformer means primary power is equal to secondary power. So the value for power, the formula for power is voltage into current. So for ideal transformer, we can say secondary power is equal to primary power. Power is nothing but the product of voltage and current. Okay, applying the condition for ideal, we get secondary power is equal to primary power, output power is equal to input power, but just substituting the values, we get the primary current as 2.27 ampere. That is option number 4. This is the required condition for an ideal transformer. If the transformer is not ideal, we can't equate primary power to secondary power. The concept of losses is indulged in step of questions. Now the next question from NEET 2023 is related to capacitance concept. One of the simplest questions, just applying the concept of series and parallel. The question says the equivalent capacitance of the system in the circuit. We have to calculate the equivalent capacitance between A and B. We are provided with 3 capacitors, 3 and 3. By just observation, we can see the 2 capacitors, that is 3 and 3 are in parallel, are connected in parallel, and the result is in series with this 3 microfarad. That these 2 capacitors are connected in, these 2 capacitors are connected in, these 2 capacitors are connected in parallel. As we all know the concept of parallel capacitor, parallel capacitor means 3 plus 3 is equal to 6. Now this 3 and the result of both is 6 are connected in series, and for series we have to solve like 3 into 6 upon 3 plus 6, that gives result is equal to 2 microfarad. That is the required option number 4. Simply by the application of series and parallel concept we can solve this type of question. Now the next question is related to carbon resistor. The question says the resistance of a carbon resistor determined from the color code. We are provided with a color code, that is resistance is 22,000 ohm plus minus 5% tolerance. The question is about the color of the third band. For this we have to just recall a numeric series and table which is relation of color with number. Okay, by relating, question can be written as 22,000 can be written as 22 into 10 raised to power 3 plus minus 5%. The first value is first color, second is second color band, and this is the tolerance, and other one is the variation gold, silver and no color. According to color band, third one is for the 3 digit number 3, that signify orange color. That is the required answer of number 2. This we have to recall the table in which there is a relation of color band with number and multiplier. Okay, the relation of number and multiplier is almost same, and the last variation is of the gold, silver and no color. We can easily predict the answer. But in this type of numerical we have asked about only the color of third band, that is third is related to orange. Okay, this is all about the questions related to NEET 2023 of class 12. In the next video we will solve some of the questions from class 12, and then we will move further for class 11. This is all about today's lecture. Thank you.